Hi, today I'm here at Endeavor 3D's booth, so thank you so much for everyone who came out. I'm Krysten Minnici from Arkema, and I'm going to be talking today about understanding and improving sustainability for additive manufacturing. And what that boils down to is 3 simple letters. We're going to go back to our ABCs today, and we're going to talk about how PA11 is advanced, bio-based, and circular. So first off, we're going to talk about advanced materials, because first and foremost, PA11 is an advanced polymer. So PA11, when we talk about advanced, we're not just talking about 3D printing. For PA11, it can be used for molding, films, extrusion, and powder coating applications. And the unique crystalline structure yields an impressive balance of properties that I'm going to get into in these next few slides. So first, when we think about PA11 versus PA12, we have that 100% bio-based aspect that I'll get into when we get into the B in our ABCs of materials. We also have superior elasticity, ductility, impact resistance, and why we're here at Endeavor 3D's booth is also to talk about the excellent powder bed fusion processing characteristics. Okay, so let's get into some of these advanced properties that I referenced to in my last slide. So on this slide here, you'll see your stress versus strain curve, where we're looking at both X, Y, and Z direction properties, since this is for 3D printing, and we all know that there are differences between your X, Y, and your Z direction. So you can see here that PA11 outperforms your PA12 when it comes to elasticity, ductility, and your elongation at break. The next property I'm going to show you here is your stress over a number of cycles, where we can see how PA11 has superior fatigue resistance when compared to PA12. And I want to emphasize again that these are all on 3D printed parts. And the last property I'm going to talk about, which I think is the most impressive property of our PA11 material, is the impact resistance. So this is PA11, purely a polymer, no additives added, where you can see here, whether at room temperature or at -30°C, that with both the Z direction and the XY, PA11 doesn't break with a 4-joule hammer, where you can see with your polyamide 12, it does not have the same performance, especially at these lower temperatures. And this is why PA11 is often a material of choice in automotive applications, where you really need that improved impact resistance in order for this to work in your car. So hopefully I've now convinced you that PA11 is first and foremost an advanced material. So next we're going to get into the bio-based aspect, which is something we're all excited about with sustainability, and especially that being a key theme at NP this year. So when we talk about bio-based, a lot of people immediately think of corn, but PA11 is different. It comes from your castor plant. From the plant, we get a castor bean. This is crushed into castor oil and fertilizer cake to become our polyamide 11 polymer that you're probably familiar with in either the resin or the powder form. So with the castor plant, this is a really exciting crop. It doesn't compete with food, so you're not worrying about taking land away from feeding the world or any of those aspects that usually people ask about when you think about a bio-based material. It also doesn't require deforestation in order to plant this crop. It's highly profitable for the farmers in this region, and on my next few slides, I'll get into what Arkema has been doing with the farmers through our Pragati initiative in the Gujarat region of India, where this is a high cash crop for the farmers there. None of the bean gets wasted. It's either crushed into fertilizer cake that goes back into agriculture or into the oil that we use as our starting block for amino 11 into polyamide 11. And then the last point is, in the Gujarat region, this is some of the poorest soil where you can't grow anything else there. So it's not like we're taking soil usage away from another crop in order to make castor. Okay, so a lot of these points I already touched on in our bio-based, and I'll get into a lot of these in the next few slides too. I think one key thing to also note here is that we take advantage of the monsoon rain cycle, so we've helped the farmers in this region use less water also. So this is though, when we talk about bio-based polymers, one of the main benefits is this biogenic benefit, where instead of having your linear model where you're taking crude oil extraction, causing permanent depletion, getting your polymer based on fossil fuel, where then your CO2 goes into the atmosphere if it's not recycled. We have a circular model where we're first taking carbon from the atmosphere to grow the crop, and then the crop becomes the polyamide 11, and then CO2 goes back into the atmosphere to be used again for crop protection based on this circular model. That's all assuming it's not being recycled, but when we get into the C and our ABCs, I'll talk about the circular aspects in the sense of recycling and our new Agiplast acquisition. So why do we care about that biogenic effect, and what does that mean for you? Well, when we think about LCA, which I feel like is the big buzzword when it comes to your sustainability aspects and what that means for your raw materials, with our poly 11 material taking into account the biogenic carbon and then Arkema's biomethane energy contract that we signed early last year, you have a 70% reduction in your carbon dioxide kilograms equivalent per kilogram when compared to fossil fuel polyamides. So what that means is we have a less than 2 kg CO2 equivalent per kilogram value. And we're working in order in 2030 to lower that by an additional 50%. So one of the things I also hinted at was our Brigadi initiative, where we're working with the farmers in the Gujarat region of India to further make this a more sustainable crop, to further help them with their agricultural practices. So this was launched in 2016. BASF is also one of the founding members of this initiative. So with the farmers, as of September of last year, we've worked with 7,800 farmers in the region, which it sounds like a lot, but there's still a lot more work for us to do. Each of the farmers in this region has a very small field of land that they're growing castor on. So we're not done with our efforts here, but we've done a lot already. So with our program, we've been able to help them get 45% higher yields in their castor compared to the government rates. They also are lowering their water usage by 21%, taking advantage of that monsoon cycle. So a lot of great benefits from this program. We're now starting to use apps to further outreach and work with other people in the Gujarat region. So now we've talked about PA11 is an advanced material, it's bio-based. The last letter I'm gonna leave you with today is circular. So with circular, in June of 2021, Arkema acquired Agiplast. This is an advanced polymer recycling company out of Italy. And what they do is they take scrap polymers and turn those into new advanced polymers. So now when you're thinking about your bio-based materials, it doesn't have to end there. When we think about 3D printing, that can mean using all of that unused powder that you can no longer use after a certain point and giving it a new life in a new polymer. So with this just explains for our circular economy outside of 3D printing, we work with materials manufacturers, we work with polymer processors, and also end consumers. So as part of this program, we work with everybody, and we want to take back your material to give it a new life. Oh, and with that, I should add, since this is a 3D printing section, you will not see these recycled polymers in 3D printing again, but they'll be used in injection molding and extrusion applications, which is some of what we're showing here. And this just shows the way our Virtue Cycle program is adapted. We either have customers that are we're collecting their material, we have customers that are buying the recycled products, and then we have some customers where it's a full loop in terms of the circularity. So thank you all for listening today about Arkema's ABC of materials. Hopefully I've left you with the easy messaging that PA11 is advanced, bio-based, and circular. So thank you.